We've been doing tests on quantitative variables. What I want to do is look at this one example where we can do things on categorical variables. It's called the test for independence. There are other ones we can also do, but this is the one we're going to be getting into, is the test for independence. The steps for a hypothesis test, again, are exactly the same. We don't really need to state our random variables here. You could, if you wanted to, state what the variables are. I wouldn't go with random variables per se. I'd state what the variables are of what did I measure categorically and what else did I measure categorically. You can state them if you want to. You don't really need to. You just want to kind of think about what those are in your mind. You will state your hypothesis. The hypothesis, the alternative hypothesis is always that the two variables are not independent. You can call it dependent, or you can just go with not independent. Even though it's called the test for independence, it really is a test for not independence. And your null hypothesis is the two variables are in fact independent. And again, you're only going to have two variables that you're working with. You're going to state and check your conditions. So we're going to state them. The first one is you're going to have a random sample. Every hypothesis test has a random sample. So that is one of the things we have to have. The reason we like random samples is because we get a much better way of understanding what is happening and we don't get as much bias going on. Your check is you would again describe the process you went through to collect that sample. The other condition is that your expected frequencies for each cell are greater than or equal to 5, which means those expected frequencies, and I'm going to show you how we calculate those. They'll get calculated a little bit later, but you want to see them be bigger than 5. And what the expected frequencies are is what you expect to happen if these events are independent. And we're going to see an example where we're kind of looking at this and show you how that works. The calculations are a bit different depending on whether or not you have a data frame or you actually just have a contingency table. If you have a contingency table, you just type in your row 1. You're going to combine them and you just type in the numbers you have on that contingency table, and then you have row 2 and you have row 3. You keep going to get all your rows. And then your data table would be row or bind. You're binding those rows together. You do your row 1, row 2, and however many you happen to have. And that makes your data into your table. You can call it anything you want. I call it data.table, but you can call it anything you want. It doesn't have to be that. If you want to look at it, you type in data.table, it'll show what it is. And then you do what we call a chi-squared test on that data.table. You do a chi-squared on the data.table with this $ expected. That will actually give you those expected values. We'll talk a little bit more about what those are. Again, if you have a data table, data frame, you would actually create this using a data table using the tally command, which we've done tally commands in the past. When you created contingency tables, you would just give it a name and save it. Then you have your conclusion and interpretation. So here's the problem. Is student success in an intermediate algebra class independent of teaching methods? Here's a summary of the data that was collected by a group. So the results, you can be either successful or unsuccessful. Successful means you got a C or more. Unsuccessful, you got a D or F or withdraw. We had lecture classes, and lecture classes, there were 741 observed people who were in a lecture course who were successful in the course. We had 926 in a lecture course who were unsuccessful. In a computer-assisted course, you had 498 who were successful, 725 who were not. In personalized instruction, you had 152 who were successful, 420 who were not. In an online class, you had 127 that were successful and 559 who were not. Where the teaching methods were these lecture, computer-assisted, personalized instruction, and online. Is there evidence that a student's success is independent of a teaching method in an intermediate algebra course? So we're going to go with, I'm going to go with my variables. I'm going to state them for just a moment. I just said you don't have to, but I just want you to see kind of what it is. What we did is we looked at two different variables. We looked at success or unsuccess. So that was one variable we looked at. And we also looked at teaching methods. That was the other variable we looked at. Next step is to state the hypotheses as in every hypothesis test. And you're going to have your null hypothesis and your alternative hypothesis. And again, I always state my alternative hypothesis first. I'm going to go back to my question. Well, my question's right here. I want to know, is there evidence that the student success is independent of a teaching method in any major course? So that is my question. Unfortunately, that actually is my null hypothesis in this case, because that really is not my question. Again, we do these as independents, but really we're questioning if they're not independent. So my real question is, the student success is not independent of teaching methods. And what we mean by that is we observe these values of what it was, but we want to find out is, do I know that if somebody takes a certain type of method that they'll be more successful or unsuccessful in the class? That's really what I'm looking at. The expected frequencies is how many do I expect of my students who take this class in a lecture format? How many do I expect to see that they actually were successful based on them being independent samples? Because remember, we always assume HO is true. Expected frequency for lecture is how many do I expect of all the people in the study? And that would be adding up all these rows or all these columns, finding how many people were actually in the study. Then we could say, how many do we expect to be unsuccessful? And then we're going to compare that with what we observed. So if they're independent, then the observed and expected there shouldn't be much difference between what we observed and what we expected. If they are dependent or not independent, we do expect to see a difference. So now let's get to our state and check the conditions. So we're going to state that a random sample of success or unsuccessful and teaching method is taken from, and again, I don't know how many people there were in this study. We'll find that out later. I probably should have figured that out before, but I could add these numbers together, find out what they all are, and find out what that is, but we'll worry about that later. So it's taken. I don't actually know how they took the study. I haven't read the whole study. The references here, if you'd like to read the whole study of how they actually took it. My guess is that they had people sign up for the classes in a certain method, and then those students would be looking at the success rates and so forth in the courses. So it's not really a random sample because the students picked which method they wanted to take, because you really can't force them to take a certain method if they don't want to. But it probably is not a big deal because it still probably is representative because there was a lot of changes, but there might be some issues with the random sample. But I would probably say that this is not known to be true, but it may be, let's just go with it. It is not known to be true. We'll just go with that. Sometimes we can't always get our random samples, unfortunately. So now we're going to state the expected frequencies. Must be greater than or equal to. And what this is basically saying is, did we have enough people in each one of the groups? So you could have a study here where you've got just not enough people in each of the cells up here, and that's a problem. And so there is why we probably want to make sure that we have that happening. And that makes then not valid. Okay. The check, we don't know that yet, so we're gonna have to wait till we actually did some calculations. So let's go do some calculations. So this one's a little bit more work because I don't actually have the contingency table set up. I need to type these numbers in, and I'm going to forget what these numbers are. So let's see. We had success. You don't have to call them row one. I'm going to use row one, so I'm going to call it success. And then my success row was 741, and then the next number was 498. Notice I put a comma after each one of those numbers. Next one was 152, and the last number is 127. So there's my row one, my success. Unsuccess, we'll just call it that. Again, I'm going to type in these numbers. The C is means just combine. Whoops. What just happened? Okay, so 926. Oh, wait, it's not typing in here for me. I don't know why this is acting weird. So let's find out what's going on. I don't know why it's typing. Oh, I bet I hit something on my computer. Let's try that. All right, let's try 741 was that first number. Ah, I seem to be having issues with typing. So let's just take that all out and try again. Success is C. And this is why it's nice having a data frame. Oh, I know why. My numlock isn't working anymore. That's why. Okay. I hate when I don't notice it. Okay, 498. That was what the problem was. 152. And 127. It looks like I accidentally typed an N instead of a comma. All right, now we'll hit enter and we'll get our unsuccess and C. And then we've got the 926. Next number is 725. Next number is 420. And the last number is 559. I now need to combine these into one thing, and I have to admit I don't have this memorized, so I always gotta like to go look up at it. So I'm gonna call this something. I might call it lecture type or something like that. I'm gonna do this R bind. So I'm gonna give it a name. Maybe I'll call it lecture or teaching to give it a name. And I want that teaching data frame or contingency table that I'm going to create to be R bind. I'm binding, and again, you can start typing it. And I wanted to bind the row success. And I wanted to bind the row unsuccess. I realize that's not really a word, but that's okay. All right, so now I've got it in here. I've got my teaching. If you want to, you can look at it by just typing teaching. And you can now see that has been written up for us and we can see what's happening. Now I can go ahead and do, and in fact, you can even put it in here. I'm going to do my chi-squared test, and I'm going to do it on this teaching. And I believe that's all I have to type in. Yep. And here's my chi-squared test. My p-value is pretty dang small in this case. My chi-squared tape number is pretty large. 174 is pretty large because, again, your center is somewhere else. The closer you are to zero, the less likely, the less chances your p-value will be bigger. The higher you are, your p-value will be smaller. So now we can get to our conclusion. And in this case, we're going to reject HO since the p-value is less than our alpha. One thing I did not do yet is that get my expected values. So, whoops, chi-squared test. And we're going to do teaching. And then here we're going to do the $ expected. And what this will do is, calculate those expected for us. So they're saying that for people who are in lecture class, out of our total number of people that are in this, we expect there to be 610. We ex to be successful. We expect 1056 to be unsuccessful. And we got numbers like 741 and 926. So we're kind of close to those, but not real close to those numbers. And you can keep going looking at all those. This is what we expect to happen if everything is fine. We are rejecting HO, so our conclusion is there is enough evidence to support that. And again, we're going to go back to our question here. Our hypothesis was right here that the success is not independent of teaching methods. So that student success is not independent of teaching methods in an intermediate algebra course. So that tells me that it's not, so we might want to be looking at how do we make it more successful? What do we do to make sure that everybody's doing okay, getting the right classes for them? Because the teaching method will in fact affect what method they have. Then there's some processes we can go through to try to determine which one's more successful and so forth. That's kind of beyond this course at the moment, but you could look at that. Let's go back really fast. I didn't actually finish the check on this, and all the expected frequencies are more than 5. So that did check out okay. All right, and that's a confidence interval. I mean, that's a chi-squared test for independence. Let's get the word correct.